Students, today class alternating current unit 6. Now 5 units are completed. So now today unit 6. In unit 6 there are two lessons are there. One is alternating current, another lesson electromagnetic waves. Now alternating current, already you know the definition of electric current. The time rate of the flow of electric charge is called electric current. The time rate of the flow of electrons is called electric current. The mathematical formula electric current symbol I equal to charge Q and time T. Electric current equal to charge by time taken. The electric current symbol capital I, charge Q and time T. The SI of electric current is ampere. Abbreviated symbol capital A. 1 ampere equal to 1 coulomb per second. 1 ampere equal to 1 coulomb per second. There are two types of current. One is a direct current and alternating current. So one is a DC and AC. DC means direct current and AC is an alternating current. Friends, there are mainly two main types of current here. One is a DC, another one is AC. DC, direct current. AC, alternating current. In DC means direct current, the flow of current remains same. The direction of flow of current remains same. The DC. So far we have studied for DC electrical circuits. Example, a resistor. This is a resistor connected with source. A DC source. Source means battery. A group of cells or a source of EMF is called a battery. In a battery, now indicate polarity, positive polarity and negative polarity. Now this is the source. In DC electrical circuits, the current do not change the direction with time. The current do not change the direction with time. That is a DC. So DC circuit, this circuit connected to DC source. The current flows in the same direction, do not change the direction. So in a DC electrical circuits, the current do not change the direction with time. This is a DC. And in AC electrical circuits, alternating current, the current varies continuously periodically with time. The current varies periodically with time. The current or voltage vary periodically with time. So the current varies periodically with time is called AC or alternating current. So here alternating voltage transmitted long distance from one place to another place is very easily. Today the power receiving where generating station to receiving station. So alternating voltage transmitted a long distance from one place to another place easily. So high voltage and low current. So now we have two types of current here. One is a DC current, another one is a AC. DC is a direct current, AC is a alternating current. The current which varies periodically with time. The current varies, current or voltage varies periodically with time. The voltage which vary like sine function with time, that voltage is called alternating voltage. So students, you note this point here, a voltage vary like sine function with a time is called alternating voltage. The current passes through the circuit is called alternating current. This is a very important point here. The voltage vary sine function with time is called alternating voltage. The current flows in a circuit is called alternating current. That alternating current means the current which varies periodically with time. This graph is very important. So here two axes are there. So the y-axis voltage or current, x-axis to taken time. So the current continuously, the current which varies periodically with time is called alternating current. Every half cycles the directions must be changed. The current which is varies periodically with time is called a alternating current. Now here two graphs are there, V versus time. The voltage vary like a sine function with time is called a alternating voltage, and current passes the circuit is called a alternating current. So now a second graph, a current versus time. The current which is varies periodically with time is called a alternating current. So today almost electrical devices may be transformer, generator, voltage regulator. We require alternating current, alternating voltage. Today almost electrical devices works you require for alternating current or alternating voltage. Now students, the two graphs are there. This is a AC waveform. The first graph, voltage taken along the y-axis, time along the x-axis. So the voltage vary a sine function with time is called alternating voltage. It is a very important point. The voltage vary a sine function. This is a sine function with the time is called alternating voltage. And current versus time. A current versus time. The current passes the AC circuit is called alternating current. The current varies periodically with time is called alternating current. So this x-axis and y-axis symbols is very important. In your examination point, x-axis and y-axis. This is y-axis. So alternating voltage, you should mention a symbol V, and x-axis time T is very important. X and y-axis representation. And here current versus time. A current continuously vary with time. The current which is varies periodically with time is called alternating current. And some here important definitions. The first one is a period of AC. Period of AC. Period of alternating current. Here voltage versus time. Voltage versus time or current versus time is called AC waveform. A graph of a voltage versus time is called a AC waveform. A graph of current versus time is called AC waveform. Now first definition here, period of AC. The time taken by the alternating current to complete one cycle is called period of AC. So this is one more question. Define period of AC. The time taken by the alternating current to complete one cycle is called a period of AC. So period symbol represent what? Capital T. Capital T is a period of AC. So define period of AC. The time taken by the alternating current to complete one cycle. To complete one cycle is called a period of AC. The number of cycles completed per second by the alternating current is called frequency of AC. This is a very important point in examination. Define frequency of AC. The number of cycles completed per second by alternating current is called frequency of AC. Frequency of AC. Frequency of AC. So define frequency of AC. So the number of cycles here, number of cycles completed per second by an alternating current is called frequency of AC. So the frequency of AC, so the value F equals 50 Hertz. F equals 50 Hertz. And one more formula, the frequency F equals 1 by T. Here frequency and period, how they are related? Inversely proportional to. So mathematical formula, frequency F, symbol small f, not capital F, and do not mention any other symbol. So the frequency F equals 1 by T. So F equals 1 by T. T, capital T is a period of AC. The time taken to complete one cycle is called period of AC. And the number of cycles completed or performed per second by an alternating current is called a frequency of AC. F equals 1 by T. What is the value of frequency of AC? F equal to 50 Hertz. So this here experiment is there. How to determine the frequency of alternating current, the frequency of AC source using electromagnet, and name of the instrument sonometer. So electromagnet used to determine the frequency of AC. So repeat one more time. The frequency of AC. The frequency of AC means a number of cycles completed per second by an alternating current is called frequency of AC. Now your graph is V and I. V and I are represent instantaneous value of AC. Instantaneous value. What is instantaneous value of AC? Instantaneous. Instantaneous value of AC. Instantaneous value of AC. The value of alternating voltage at any instant of time is called instantaneous value of alternating voltage. The value of alternating current at any instant of time is called instantaneous value of alternating current. So now you get maximum value. This is the maximum. Your graph it shows that maximum amplitude. Your peak value or amplitude. That the V naught or maybe Vm, symbol Vm. Vm. Here current maxima. Here Im or I naught. So Vm or Im are amplitude value of AC. Peak or amplitude. The maximum value of alternating voltage and the peak or amplitude. The maximum value in graph which shows that Vm. Second graph, maximum value of alternating current. So here Im is Im. The instantaneous value of AC, a peak or amplitude of AC. So instantaneous, the value of alternating voltage at any instant of time is called instantaneous value of alternating voltage or current. Peak or amplitude, the maximum value of the alternating voltage or maximum value of the alternating current. In a graph it shows this point here, peak value or amplitude. This is the maximum value of alternating voltage or alternating current. The symbol, some textbooks may be Vm or Vo. So maximum or peak value of alternating voltage, so you should mention Vm or Vo. The peak or amplitude of maximum current Im or Io is a symbol. After, write the expression for instantaneous value of alternating voltage and current. The two important mathematical relations. So the first one, V equals Vm sin omega t. Write the expression for instantaneous value of alternating voltage V equal to Vm sin omega t. Write the expression for instantaneous value of alternating current. So I equal to Im sin omega t. Now there are two equations V and I, which are represents instantaneous value of alternating voltage, instantaneous value of alternating current. So V and I, which represents the instantaneous value of alternating voltage and instantaneous value of alternating current. So already I told that instantaneous, the value of alternating voltage at any instant of time is called a instantaneous value. So V and I are represent instantaneous value. Vm, maximum or peak value, the maximum amplitude or peak value of alternating voltage. Vm, the peak value of alternating voltage. Im, the peak value of alternating current. And sine function. So simple harmonic function, sine and cosine function, they are sine function. So the voltage vary like sine function with time is called alternating voltage. So sine function. This kind of wave is a sine wave. So in this lesson, voltage, how vary with time as per sine function. This is a very important point here, students. The voltage vary like sine function. Sine function with time is called a sinusoidal wave or sine wave. So a sine is the symbol V equal to Vm sin omega t. So I equal to Im sin omega t. Omega is an angular frequency of AC, angular frequency, and t is a time. The two important mathematical expressions here, V equal to Vm sin omega t, I equal to Im sin omega t is very important. The two mathematical expression, this unit alternating current. So once I repeat one more time, V equal to Vm sin omega t, I equal to Im sin omega t. V and I are represent instantaneous value of alternating voltage and current. Vm and Im are represent, so the peak are amplitude of alternating voltage and current. Sine function, the voltage vary, sine function with time is the sine wave. So in this lesson, the waveform is the sine function. Voltage or current vary, a sine function with time is called sinusoidal wave or sine wave. So this sine omega is an angular frequency, t is a time. The two are very important mathematical expression in this lesson. Vm equal to Vm sin omega t, I equal to Im sin omega t. On what basis the two equations are written here? So last point, AC generator. So you already proved E equal to E naught sin omega t. In AC generator, instantaneous value of EMF E equal to E naught sin omega t. E is the instantaneous of EMF. E naught is the peak or maximum EMF sin omega t. So two equations are there. V equal to Vm sin omega t, I equal to Im sin. How to write the two equations? What basis? With the help of this formula, E equal to E naught sin omega t with refer AC generator. So the last unit AC generator. So this equation E equal to E naught sin omega t, on the basis you write V equal to Vm sin omega t, I equal to Im sin omega t. V and I are represent instantaneous value of alternating voltage and current. Vm and Im are peak or amplitude of alternating voltage and current here graph. This is the maximum value is called a peak or amplitude. And sine function omega is an angular frequency, t is the time. So here the important definitions here: period of AC, the time taken to complete one cycle is called period of AC. The time taken by the alternating current to complete one cycle is called a period of AC. Frequency, the number of cycles completed or performed for 1 second by alternating current is called frequency of AC. The frequency of AC F equal to 50 Hz. How to determine the frequency of AC using electromagnet and sonometer experiment? Instantaneous, V and I are represent instantaneous. The value of alternating voltage at any instant of time is called a alternate instantaneous value of alternating voltage and current. So V equal to Vm sin omega t, I equal to Im sin omega t. V and I are represent instantaneous value of alternating voltage and current. Vm and Im are represent in a peak or maximum peak or amplitude of alternating voltage and current. Students, some important relations here. Relation between RMS. RMS means root mean square value of alternating voltage and current. RMS, root mean square. Root mean square. So V naught is a peak or amplitude. Write the relation between RMS and peak value of alternating voltage. So formula Vrms equal to V naught by root 2 is very important, 1 mark question. Write the relation between RMS and peak value of alternating voltage. So Vrms equal to V naught by root 2. Similarly, write the relation between RMS and peak value of alternating current. So now IRMS equal to I naught by root 2. Alternating voltage Vrms equal to V naught by root 2. Alternating current IRMS equal to I naught by root 2. And second one, write the relation between mean and peak value of alternating voltage. So this is the first relation. Now the second one here, write the relation between mean and peak value of alternating voltage. So Vm, mean or average. So Vm equal to 2 by pi V naught. And current Im equal to 2 by pi I naught. Write the relation between mean and peak value of alternating current. Im equal to 2 by pi I naught. And third one, write the relation between mean and RMS value of alternating voltage. So Vm, mean or average. So Vm equal to 2 into root 2 by pi Vrms. This is the relation between mean and RMS value of alternating voltage. RMS means root mean square. Here M means mean or average. V naught is a peak or amplitude. So this symbol is very important. So in RMS, root means square. V naught is a maximum or peak. Vm means mean or average. Now we write the relation between mean and RMS value. Vm equal to root 2 into root 2 by pi Vrms. Now we are current. Write the relation between mean and RMS value of alternating current. So I mean equals 2 into root 2 by 2 into root 2 by into IRMS. It is very important, the mathematical relations for alternating voltage and current. Here write the relation between RMS and peak value of voltage. Write the relation between mean and peak value of alternating voltage. Write the relation between mean and RMS value of alternating voltage. So the three equations with alternating voltage and alternating current is very important. So now we practice the three equations. Vrms equal to V naught by root 2, Vm equal to 2 by pi V naught, Vm equal to 2 into root 2 by pi Vrms. So here alternating current equation.